Hello and welcome to this ETSI webinar. My name is Gavin Craig and I'm the Senior Technical Content Officer at ETSI, and I will introduce today's webinar. This webinar has the title OSM Release 12, and it will be presented by ETSI members Francisco-Javier Ramón from Telefónica, the ETSI OSM Chair, Gerardo Garcia, Telefónica TSC Chair, and Ramesh Ramanathan from Tata Elisi TCSE member. They will be followed by a question and answer session should time allow. And the session will be commenced by Francisco-Javier. It is scheduled for last up to 90 minutes, including Q&A session. Before I hand over to Francisco-Javier, I would like to remind you of some quick points about the webinar today. A recording of this webinar will be available on demand a few minutes after we've ended it, at the same location as where you are right now. Please feel free to ask questions by clicking on the question button. We'll handle questions at the end of the webinar. If we don't answer your question at this time, don't worry, we'll get back to you after the webinar by email. The slides in PDF format and other links have been provided in the attachment section so that you can download them. Now over to you, Francisco-Javier, to start the webinar.
Thank you, Gavin. Welcome to OSM Release 12 webinar, where we'll do a quick recap on what comes in the new OSM release and what are the use cases where OSM community is working on right now. So these are the sections of what we'll present today in today's webinar. First of all, we'll explain why OSM is useful and how OSM can help you in your telco cloud journey. And we'll also give a brief overview on where what are the additions in OSM Release 12 on what OSM was doing already. And then it will follow a couple of demos. One first demo will show the capability of upgrading live CNF that will be driven by Gerardo Garcia. Later on, we will have a demo on, actually you should not miss this one, on healing and scaling in a massive sports event, where we will be illustrating many of the new capabilities that OSM Release 12 brings in very practical terms. I really think that this will be quite illustrative on the power of the latest OSM releases. So, well, first of all, for OSM is well known in industry, but everywhere is good a recap. Why OSM? What does OSM do? I mean, the OSM what gives you is the capability of creating networks as a service and being able to manage them conveniently later in virtual environments. This means that it will be in charge of managing all the low-level details or setting up those network functions and interconnecting them and letting them ready for use. In IT jargon, it will be a sort of a specialized platform as a service for network functions, but it's more specialized because it lets you to do some special stuff that is required for networking. In particular, complex connectivity will help you with that, with all the PA and relay scenarios, and the relations between the network functions as well. So that will be greatly simplified thanks to OSM. The other part is that it gives you all that is needed to manage that network function later on, and includes a powerful day 0 and day 1 together with a complete day 2. So you can rely on OSM to manage your network functions almost entirely, or just setting up as a PaaS platform will do in an IT environment, but oriented for networking, right? So, well, this is following the well-known paradigms in IT and public clouds, but extending them to connectivity and all the adherence to physical environments and connectivity that are required in networking. The thing, as I said, I mean, the power of the solution is that it isolates you from many of the gory details of the different type of infrastructure. So you will work in models, and it will not matter in which virtual infrastructure management, in which cloud you are deploying, or which SDN you are using. That OSM will take care based on the model will deploy and manage the life cycle. And of course, OSM is also equipped for a long time to work in scenarios that cover many sites and are highly distributed if needed, right? And also private and public cloud. So that is quite. I mean, that simplifies a lot the picture. The other part is that OSM can combine physical network elements, virtual machines, and containers, Kubernetes workloads, create all the combinations of elements that you need in your final network service. And also, as I said, it takes into account all the techniques that are required to accelerate and guarantee a predictable performance in that plane. Okay. Well, the key here, and I think this is, if you need to summarize what OSM gives you, is this one. Everything in OSM is model driven and is designed to be as portable and reusable as possible, and to encapsulate and codify all the potential complexity or all the operational experience that is required at low level, that is encapsulated. So OSM works with network service and BNF packages that are instantiated with the same package. You can instantiate it in different clouds, and you just need to feed it with the parameters that customize the IP addresses that you want for that deployment, the keys, and anything that is required to security, but reusing the same template regardless of the cloud, and OSM will take care for you. Okay, so the thing is that the OSM package is a central piece in OSM, and we spend a lot of time on designing and improving our OSM packages so they can incorporate all the new functionalities that are coming in clouds without compromising the being agnostic to the different technologies of cloud, and at the same time being able to parameterize successfully, so we are not hard coding things in our packages, and at the same time we can provide the reasonable capabilities for the E2. Okay, so all that is part of the OSM main duty, and all that is encapsulated in OSM package. That's why it's that important. It's essential to let you work in a convenient fashion. This has, you might be wondering, okay, but I know how to deploy things manually, so why should I care of orchestrating these things? Well, first of all, this reduces significantly the complexity thanks to this abstraction and this layering that simplifies and removes things that do not belong to the actual design of a network function. So you don't need to be distracted on the details on the specific APIs of a specific cloud. You can feel relaxed on that. It's also reliable for the deployment in multiple locations. As I said, independent of the type of cloud, it's very agnostic. Actually, it's open source, and this is the best guarantee that can be used by anyone. It's reliable for testing, super reliable. It helps you minimize errors a lot because you are minimizing manual intervention. So if you are testing it once, you can reuse the same that you have tested, making sure that since it's encapsulated in your package, you are not adding much complexity. It minimizes the time to market for second deployments. Once you have the package, you are done. The capacity growth is much simpler, even among different clouds. You can even plan to move workloads. Actually, we show one demo in the last webinar about that. And well, redundancy schemas can be improved thanks to that capability and the modeling, because we can rebuild the workload whenever we need without additional engineering, and however we are reducing effort. Right? Well, Osm community is big, 150 members of industry and academia, of distributed geographically everywhere and every single layer of the cloud and IT and network. So we are quite comfortable with this community. We also have the OSM ecosystem, where this is a opt-in list where companies are listing themselves on their offers related to OSM, and that have proven compatibility and alignment with OSM. That interoperability is key, obviously. So this is the tip of the iceberg, but shows a sample of where we are in this respect. And well, release 12, that is what brought us here. Why release 12? If I am tested release 11 and I'm happy, why should I consider upgrading to release 12, right? Well, release 12 adds a lot of new features that are quite useful, and some of them were quite demanded on people who were heavy users of OSM. Key one, we can heal network functions, and both manually or automatically. We'll see one of the demos where we will be illustrating that. Support of SOL003, OSM can now work as GBNFM if we want to. In some scenarios might be useful. We are improving the life cycle of the network service, and we can upgrade the packages and the artifact to manage the network functions. Like we'll see that in the same demo that follows this introduction, and we can even adapt the network service. We have improved our support of anti-affinity. We are extending the day 2 operations related to Kubernetes network functions, where there are day 2 operations that cannot be templated in Helm chart, for instance. That kind of stuff is adding right now. And the security, several improvements here and there, where we are continuously improving the security of the system. This is in any real software, this is always an ongoing work, right? Also, we have added, we decided to add long-term support releases, the even ones, release 10, release 12, release 14. They are long-term support. That means that they will be supported by the community for 24 months, not precluding that in commercial offers that can be extended, of course, but only by the community you have the guarantee that they will be live and patched for 24 months. And at the same time, we have short-term support releases that allow us to continue in the innovation and incorporate and validate features, either mature or even more experimental, and we have room to refining, so they land in an LTS. So I think it's a reasonable compromise, and it serves well the different uses that OSM is having in industry and academia. Well, these features are obviously not the only thing in OSM, because it's release 12. So you can imagine, since release 0, that we follow a line of features and capabilities that are provided by OSM. So since a couple of years ago, we realized that it was almost impossible to illustrate them theoretically, just enumerating and explaining them. It was much better to show them in practice. So that is how we have been doing and how we will continue to do it. And that's the reason why we will illustrate some of the new capabilities with 2 demonstrations. So that's all about the introduction. So I'll give turn to my colleague Gerardo Garcia, who will present the first demo. Over to you, Gerardo.
Okay. Thank you, Javier. So now I'm going to illustrate in next demo one of the features coming with release 12. that it's the upgrade of a network service. In this case, we will use it to upgrade a CNF. A CNF, as you probably know, is a containerized network function. That means it's a network function designed to run in a container framework, typically in Kubernetes clusters, right? And so what we will do through the demo is, well, I will illustrate this whole upgrade, okay, that has been included in Release 12. The upgrade of network functions introduced in Release 12 rely on a new concept that is called Descriptor Revisions, or also package revisions, right? It's a user can upload new versions of BNF packages or network service packages, right? And these revisions that are added by the end user are managed internally by OSM. So from the point of view of the end user will continue seeing a single package, right? But those revisions are there behind the scenes, right? Existing instances that let's imagine that we have a running network function instance that well was running for some time, right? If we add a new version of the network function, the existing instance will continue using the original revision, the original version, right? However, new instances of the network function could use or will use the latest revision. So this, as you can imagine, this has led to a major review of the different workflows for the onboarding of packages, the update of the packages, and also for the instantiation and termination, right? All the workflows need to deal with this new revision concept. So now let's understand much better, okay, through a use case, okay, because all this is hidden for the end user, but it's happening behind the scenes, right? So I'm going to illustrate now with a demo, well, the live upgrade of a CNF. As I was mentioning before, the CNF is a network function that is containerized. We will instantiate a network function, well, a network service using that network function, right, in a cage cluster. And we will see it up and running, and we will execute a day2 primitive over that CNF. As you know, network functions in OSM could be formed not only by let's say, the instructions for deployment, but also with specific operational and configuration elements. That's what we call the execution environment. So we are able to execute primitives over the network functions, right? In this case, we will run a primitive over that network function, and when we will see that it's working well, and then we will upload a new revision of the network function, right? Second revision. This second revision will add another primitive. Okay, let's imagine a situation where we have a network function that is already running, and the elements or the execution environments used to manage that network function have defined a set of primitives. We might want at any moment in time to add new primitives to our network function, and this demo is illustrating this use case. So we will upgrade our network function package with some primitives, and then we will also well, upgrade the network service to use this new revision of the package. And finally, once we have this new version of the BNF, we will execute a new day2 primitive, the one that was added with the new revision over that CNF. Okay, so let's start with making the CNF up and running. So I'm going to share my screen. You can see here, well, the UI of OSM. I will log in. We can see here that we have the UI of OSM. We have already registered, well, different Vim accounts. In this case, we see Azure, GCP, and also a Vim at ETSI with an account that it's ETSI Vim Telefónica. This is an account in an Openstack Vim that is running at ETSI. That's the one that we will use for the demo. And we have also here a cage cluster. It's ETSI Cage Telefónica that is registered in that Vim. So that cage cluster is running in the previous Vim, ETSI Vim Telefónica. So I'm going to onboard a BNF package and a network service package, and I'm going to instantiate it. So first, let's drag and drop the BNF. So I have BNF, version 1 of the BNF. This one here. This is the CNF that I was mentioning. Okay, let's check the content of that CNF so that we see it. We see that it's a CNF with a KDU. A KDU is the struct that we use in OSM to define each of the deployment units to be deployed in a Kubernetes cluster. So a network function could consist of BDUs, that it's PMs, right? KDUs, Kubernetes deployment units, or PDUs, physical deployment units. So in general, a network function in OSM could be modeled with a combination of these three kind of deployment units. In this case, we have a single KDU. This KDU is based on a Helm chart. In OSM, KDUs could be modeled by Helm charts or UU bundles. And here we are using a Helm chart, the stable OpenLDAP. It's an OpenLDAP server that is the one that will be deployed. Yeah, as part of that, of this BNF, we are also including a charm. That charm is already contained in this binary that is part of the package and has a primitive, a single primitive that is get user info. With this primitive, we are able to get information from the LDAP server about a user by providing the common name and the domain component. So, CN is common name and the domain component, DC. By providing these two parameters, we are able to get the information of a network function, right? So this is our BNF. The network service is pretty straightforward. Let me onboard it. And we have here the network service. Well, the network service is pretty simple and consists of a single BNF, okay? That is the OpenLDAP based on this BNFD, okay, BNF package, okay? So we have our BNF package and our network service package. Now let's create an instance of this network service package, right? So I'm going to create a new network service. I will call it, let's say, LDAP. As description, I could tell something like LDAP server for webinar OSM Release 12. Based on this network service, the Vim account will be ETSI Vim Telefónica. The cage cluster will be automatically identified from the Vim, right? Because the cage cluster was already registered to that Vim. And we are going to pass some parameters in the instantiation parameters, well, to provide a way to access to the OpenLDAP server, etc. Right? So that's all, and create. Now, in a minute or so, we will have our LDAP server running, right? So meanwhile, let me go back to the presentation. So the idea is that we had Cnf up and running in cage cluster. That's what we have covered so far. We will see that then the network function is up and running, and we will execute a day2 primitive over Cnf. Basically, we will use the primitive get user information, get user info to get some information from the common name and domain component, right? So now let's move to the execution of the primitive. We have this here. If I refresh, it's still being deployed. Well, hopefully in a minute or so we will have it. This is the BNF instance that is being created. And we have it. We have here our LDAP instance, and this is the BNF instance, right? The CNF that, well, it's already deployed, right? And it, let's say, controls the whole deployment of the network function. So now let's execute an action over this network service, right? So we are going to execute a primitive. We see here it's a primitive at KDU level. It could be at different levels. It could be a network function level. In this way, in this case, it was modeled as a primitive at KDU level, but it could have been modeled as a primitive for network function. We will do it on the OpenLDAP network function inside the network service. So in this case, it's pretty simple because the network service only has a BNF or a network function, right? The KDU will be LDAP. And the primitive is get user info. As you can see here, this is the only primitive that we can run because it's the only primitive available. Okay. And now we will add some primitive params. We will provide a common name and a domain component. So for instance, I know that there is already a user that is admin in my LDAP server and in the domain example.org. And I will execute. We will check the history of operations to check that everything is running. We see the instantiation was working and the action that we are running right now is in process. It has completed. Okay, so we have run the action and, well, as part of the output of that action, we can see the output here. In the output, we could see that we have some information about the CN, the description, the object class, the user password. Okay, so that's part of the information that is provided for the LDAP server, right, by the LDAP server. Okay. Well, so the execution of a primitive was working well. Now we are going to do the next steps, right? Let's go back to the slides and see the next steps. Now we are going to do step 3, upload new revision of a CNF package. Okay. For that purpose, I'm going to well, illustrate in this case that it's possible to run all this also through the command line. Okay. So I'm going to run this update of my package. I'm going to update using the command line the package OpenLDAP KNF. Okay. I'm going to provide a new version of the package. You see here, right? The version 2 of the package. That is a version that contains already a charm or an execution environment with one extra primitive that we will see. So I'm upgrading the package right now. By upgrading the package, we are not upgrading yet the instance of the network function that is running. We are only adding a new revision of the package in OSM. Now, if, for instance, if we check right now if we check the BNF packages, we should see here the new package, right? We see here that this package right now does not have a single primitive get user info, but it also has another primitive that is get user attribute. So it's very similar to the previous one. It's like by providing the CN and the DC. The previous one, we were able to get the user information. Right now, we are getting a specific attribute. So if we specify the common name, the domain component, and the attribute, we will get the information only for that attribute. Okay, in the LDAP server. Okay, that's the primitive. Okay, pretty simple. But as I was mentioning before, this has not yet been applied to the network service instance. So we need to upgrade our LDAP server. Let me recap the operations that we have done so far. We have done instantiation. We have done the execution of a primitive. Now we are going to upgrade the network service. So a new action, NS update. This is the new action that has been added in release 12. And with the update type is change BNF package. There are also other network service updates that are possible. For instance, it's possible to remove a BNF from a network service. so that well, it's an interesting case when we might want to remove BNFs that are not in use already in production, right? And we might want to remove them from a network service. That also has been added in Release 12. In this case, we will update the BNF package to be used by a specific network function. This change will be applied to the OpenLDAP network function in the network service, and we are telling also what package we should use. In this case, obviously, is the same package, OpenLDAP KNF, right? So we will update. It's asking us for confirmation. We say yes. Let's proceed. And the update should be more or less straightforward, because the only thing that has changed is the charm, the execution environment, let's say, or the element in OSM that is in charge of running day 2 primitives against the network function, right? So if I refresh right now, it has completed, right? So the update has been done. Now it's time that we check that our new, let's say, network function with the new operational environment, the new execution environment is working well. So now we are moving to step 5, execution of the new day 2 primitive over the CNF. So for that, we go here in this instance and we click on exec primitive, KDU level primitive again, open LDAP, KDU. And now you see here that there are 2 primitives. It's possible to run the second primitive that we have added, right? In this case, get user attribute. That's the one that we are going to use. This primitive has 3 params in this case. So admin, example.org, and let's request only the description, right? There are a few in the registry of the LDAP server for each user. There are more information. Let's get only the description, right? We will execute. If we check right now the history of operations, we will see that the action is running and it's been completed. And if we check the status and the information here, we see that, well, besides this read time that is always provided and it has not been removed here in this output, the only field that appears here is the description, right? Well, so that's a pretty simple example, okay, on how a network function can be upgraded. In this case, Cnf was upgraded. The upgrade was used, for instance, to update the charm or the execution environment that is in charge of the configuration or the day 2 primitives. Okay, that's what we have upgraded only in this example, but we will see in next demo other cases for the upgrade of a network function. Okay, so for instance, you could think of very interesting scenarios like upgrading, for instance, from a network function that doesn't have a charm to a network function that has a charm and it's adding some primitives for configuration, right? And that could be also a very interesting use case. Well, and that's all about the demo of the live upgrade of the CNF. I will right now pass the turn to my colleague from the TSC, Ramesh.
Thank you, Gerardo. Let me go ahead and share my screen here. So from Francisco and Gerardo, you would have seen the features that open source MANO offers when it comes to fulfillment, assurance, operations, and how friendly we are towards cloud native applications. So in today's demo, we are the next demo, we can kind of put it all together, where we are going to focus the power of open source MANO in a practical use case with specific focus on service assurance. Since when you take operators, when it comes to your net promoter score, in terms of quality of experience. What is very impactful is service assurance to ensure that quality of service and continuity of service. And that is where OSM shines. And we are going to demonstrate that to you today using a very practical example of a sports event. So for today's demo, we'll assume the World Cup, the FIFA World Cup that's coming up in Qatar in November 2022. So when you talk about a World Cup, we are talking about millions of users, not just in their homes, but we are talking about thousands of users, tens of thousands of users in the stadium who are going to use the new age applications like virtual reality, AR, VR, volumetric videos to share on social media. And we need a network that can both handle the large traffic for viewership as well as this in-stadium crowd demands. And that's where our operator has, we're going to walk through this using a hypothetical operator and see how open source MANO helps to solve the problem to give the right experience for a global event like FIFA. So we talked about a couple of use cases. Right? We talked about millions of users who want to watch. And we talked also about the need for a network that can manage new age applications that are going to run on the edge. So that's where we see our operator building a network with an AMF core in the core and UPF in the edge to cater to these low latency applications, as well overall as a scheme, a robust 5G network that can handle this kind of traffic loads. So let's go ahead and build this network using OSM. So this is the opening landing page of OSM, as you would have seen in the prior demo. So I'm going to go ahead and launch these instances to begin with, and then I'll walk you through what these services are. So I'm going to launch the 5G AMF to begin with. I'm going to put it on the core like we saw in the diagram, right? Control plane on the core, data plane on the edge. So that's the flexibility that OSM brings in, where based on the need of your application and use cases, you can define your own placement policy. So I've gone ahead and created an instance. So let's see what happens behind these instances, right? So the building blocks of a network service are your virtualized functions. So you see here two virtualized functions, AMF and UPF, the building blocks of our 5G network. And these are bundled together as two services, right? The respective services for the data part and the control part. So I just launched one of these services. So let's go and look at NS instances. So the launch is in progress. There you go. So I had the UPF already deployed for the sake of time. I have deployed the AMF now, pretty instantaneous. We see both the UPF and the AMF up and running. So let's go to Prometheus and take a look at this. So we see that the VM is up and the status is 1, right? So the VM is up. Prometheus has been able to detect the fact that both the network elements are up. So that's what so when we talk about assurance, we talk about data collection, we talk about categorizing it in a time series database. That's where Prometheus comes in, where it can connect to different type of NFVs. It can be Kubernetes, it can be OpenStack, get this data, catalog it, and present it for analysis. So this network is up and running. So now users will be able to watch the FIFA. We have also provided edge services to ensure in-stadium experiences. However, things don't always go as planned, right? There can be a variety of issues. We're going to look at two main issues that are always possible and see how OSM solves the operator's problems. The first is an outage. Right? So outage can happen for multiple of reasons. There can be a power trip in the data center. It could be a rack that got disconnected. It can even be as simple as one of the servers running the AMF went down, right? Just simple hardware failure. So what happens in this case? As we talked about earlier, the paramount importance is service continuity. So how are we going to deal with this AMF going down? So let's go ahead and simulate the scenario. So first, to simulate this scenario, I'm going to log on to Openstack. And of course, we are using Openstack as one example NFVI here. It can be as we want to. So I'm going to go ahead and kill this instance. And I'll explain to you why very shortly. So I'm going to go ahead and delete this instance. So by deleting this instance, I have simulated this failure we talked about, right? The AMF part failing. So what do we expect OSM here to do to assure service continuity? So here is where the feature of auto healing comes in, where OSM has the ability to read the NFVI, understand the current statuses, and based on the status, take the required recovery action. So in this particular case, of course, it can be a variety of error scenarios, right? So the reason I deleted it is to simulate a scenario where, for example, as a hard fail stop, the server went down, like a power trip, for example, right? So it could be it could be a hard fail. It could be the VNF for the CNFs going into an error scenario. It could be network connectivity issues. So for a variety of error scenarios, we have modeled recovery actions in OSM. So in this particular example, the expectation is now OSM has to detect that the AMF has gone down and trigger the healing process so that AMF comes back again and service is seamlessly available for the end customer. So let's go ahead and take a look at Prometheus. So as you can see, the AMF node here, 5G AMF, the status is 0. So this is the power of OSM, right? Where instantaneously we are able to get the data and do a assurance action. So OSM has detected that the AMF is down and it's going to trigger the healing process. So how does this happen? How does OSM trigger the healing process? How does it know what exact actions to do? So let's go ahead and look at the descriptor to understand this. So let me go ahead and open up the AMF descriptor. See, first to begin with, before I even walk through the descriptor, when we talk about OSM, even if we were to view from an ETSI perspective, it's a zero-touch automation engine, right? So what do you mean by zero-touch automation? All we need to do is specify our intent, right? Specify an intent in a descriptor, which follows a very simple, easy to use YAML model, and all the operations are completely abstracted from the end user, right? Implementation is completely abstracted, taken care by OSM. All the end user needs to do is specify his intent, and this intent can be for fulfillment, it can be for assurance, which is what we're going to see right now, it can be for operations. Specify your intent, and the implementation is completely abstracted and taken care by OSM. That's why OSM is a zero-touch automation engine. So let's look at how we have mentioned this healing intent in OSM. So that's what you see right here, right? Very simple, very easy to use. So we have created a healing policy here where we have given a name for it to be tracked in policies. We set the policy for healing. So we offer granular control at the for the assurance actions as well. For example, do you want the recovery to be automatic, or do you want to report it to an NMS system, so that there can be a notion of hierarchical policy to decide what kind of actions to take, and then what do you do on what kind of action do you take based on the policy. For example, here we have redeploy. It can be a respin, a restart, and then we have a cooldown timer. So cooldown timer's purpose is to retry the heal, because sometimes that would be a connectivity issue. For example, we talked about the power trip scenario, right? So there's no way to heal till the power comes back, right? So the cooldown time is the timer after which a retry operations happen. And then we also offer control on whether you want to run the day 0 or the day 1 operations again. So here it's given as false, but after post healing, if you want to redo the configurations, we support that as well, right? So in a simple descriptor, you talk about the kind of policies you want, and kind of actions, and then OSM takes care of the rest, right? So let's go ahead and take a look at what happened right here in terms of the healing. So let's go to history of operations. As you can see here, so history of operations gives you the entire history of what happens in the lifecycle management of that virtualized network function. It is available both in the UI as well as catalog as logs in Elasticsearch for further analysis. It can be for analysis for improvements, forensics, etc. So here we see the AMF we had instantiated in the beginning of my demo. We had created an error scenario, and OSM has successfully healed it and ensured service continuity for our operator, right? So this is an example of OSM having the intelligence to do closed loop assurance for our end customers. But having said this, this can be done in a hierarchical manner as well. We do have APIs to trigger here a heal from the northbound as well if there is a centralized OSS system. So this is a scenario number 1. Let's get to a scenario number 2, right? So before that, before we go to that, I'm going to increase the traffic in the network to 100%, right? So I have a traffic generator, and I'm increasing the traffic to 100%. Let's discuss why, right? So the AMF was down, and now the AMF is up, and the network is up and running. So let's fast forward on time. Let's go to November 20th, 2 months from now, right? November 20th, Group C FIFA World Cup match between Argentina and Saudi Arabia. So the match starts, and this person steps onto the field. For whatever reason, now the operator sees a huge spike in traffic. Hundreds of thousands of people are turning on their mobiles. The in-stadium volumetric videos and other new age edge application, the usage here is a huge spike, right? So what happens to the network when these kind of spikes happen, right? It can choke the network, it can create bottlenecks, and potentially even collapse the network, right? So the operator needs a way to combat the messy effect. So what's the operator going to do? We need a scaling policy, a type of scaling where the network on demand can react to these situations, and it can scale, and it can take care of the extra traffic. And this scaling, again, we can do it as a closed loop policy or through the northbound. So since we already saw closed loop for healing, here I'm going to do it through the northbound for you, where from an OSS system, we can get the alarms for the choke in the network and take an appropriate remedial action, right? So before we go to that, let's see what our stats say here. So I'm going to go ahead and look at our Prometheus. As you can see, since I had increased the traffic to 100%, OSM with the instantaneous service assurance engine has detected that and has created an alarm in the system. And of course, this is Prometheus, where it has captured the metrics and it has seen that the traffic has spiked to 100%, right? So now we need to quickly get in, remedy the network before there is an outage or a crash. So what I'm going to do here is I'm going to do an NS update where I'm going to create a scaling policy for the UPF. So the UPF can detect this traffic, scale out, and balance it out for the end users, right? So let me go ahead and let me go ahead and create the scaling, and then I'll walk you through it. So I'm going to go here, same procedure, right? Again, just in time. We're just going to do it in the descriptor. Everything else is abstracted out by OSM. So I'm going to go here and add a scaling policy. So what I've done here is, let me just quickly check this. Just 1 second. There you go. So I have added a scaling policy, which I will walk you through shortly. But let me just go ahead and trigger the NS update first. So I have updated the package, and let me go ahead and check once if the update is applied. Yes, the update has come through. Good. So let me go ahead and do the NS update first, and I'll walk you through this. So as we saw in the previous demo, the update will happen on the running instances, right? So what we want to update here is the UPF, the data path. We want to scale out the data path to combat the messy effect. So I'm going to go ahead and scale it here. So I go to NS update. I'm going to change the VNF package. I'm going to give it VNF ID, and I'm going to update the NS. Okay. So what did we do here, right? So I'll walk you through step by step. So initially, to begin with, I had edited the descriptor, the intent, right? I had added the scaling policy. So let's walk through the scaling policy. So to begin with, scaling policy gives you an opportunity to set policy based on different parameters. So these parameters can be infrastructure based, for example, CPU, memory, network. That's what we're using CPU here as an example. It can be application based. For example, you have a load balancer, you want to scale out once the number of concurrent connections are over, say 10,000, for example, you can do that too. So either based on infrastructure metrics or service KPIs, you can set the scaling policy, and then you can set thresholds for them, right? So for LT is less than, GT is greater than, so you can define a range. So what is a range with which I see this particular metric and I want to take some kind of a corrective assurance action, which here is scaling. And then the scaling the kind of scaling you want to do, it's automatic. So there is no prompt from the end user or a need to get an approval. We can have a notion of governance if required. A cooldown time again is to ensure that before I try to rescale, the amount of time I wait to see if the scaling operation has been successful, right? Because we need both a mechanism to successfully retry to ensure scaling works, as well as a checkpoint to ensure that we are not spinning up more scaled instances than what is required. So this is your simplified scale policy. And with this scaling policy, what's going to happen here as well is, like I said, in the previous example of heal, there was closed loop. This was more about us triggering the scaling by using the NS update. So what did we do in the NS update? After updating this descriptor, I called the NS update to OSM to update just the policy of this particular network service, right? So when it comes to NS update, we provide complete flexibility based on the use case of the customer, right? For example, in this particular use case, the need is just to introduce the scaling policy so the network can survive the messy effect. In other scenarios, the NS update might be that you want to change the image to the latest version of the software. In other scenarios, it could be you want to do both, or if you have a service chain, maybe you want to add a VNF, you want to remove a VNF. So based on the scenario of the NS update, as per SOL5 specification, we give you this variety of options so that you have an optimal update experience. In this case, we only updated the policy. We have not touched the running instance, so there's no issue about service continuity. And once we do the NS update, we have also, even before that, included the notification section, right? So I talked about how OSM can notify an higher layer. It can be like an NMS, like Netcool. It can be an OSS system where these kind of alarms are being sent out to the higher layers, so the higher layers can take the required corrective action, right? When we ran the NS update, what did we do? We took a corrective action from the higher layer, right? So how did the higher layer know? Because OSM has a fantastic mechanism, a very, very strong notion of alarms through which it can send to a higher layer so that the alarm correlation can happen and the corrective actions can be triggered. So here is how, even this is to the descriptor only. Here, for example, we have modeled the different types of alarms, what is the URL to report those alarms to, and of course, as you can imagine, in any alarm management system, you need a way to register the alarm and you need a way to clear the alarm. So that's what you see here as alarm, okay to clear, and then insufficient data to give alerts that we are not able to collect the metrics, right? And then what should I raise the alarm for? Again, we have an alarm policy where GT is greater than. So we are saying if the CPU threshold is greater than 60%, please raise an alarm to the NMS, right? So to raise an alarm, all you got to do is the descriptor is talk about the destination, the HTTPS, again very secure, as well as what is the policy to raise the alarm for. So let's go on to see if you got the alarm. There you go. So if you got the alarm as well. So I have an NMS simulator here which has received the alarms. As you can see, the alarm has been generated for the CPU metric since it's greater than the threshold, and we have categorized it as critical, right? And once this alarm is reached, the corrective action has been taken, which is the NS update. So which is what I will kind of in a picture wise show it to you as well here. So we have the messy effect, and then what we have done here is we have scaled out and created another UPF to handle the extra traffic, and with this the network is up and running, right? So to summarize, when we saw the healing action, it was closed loop, right? So we brought down the AMF, and OSM in closed loop without having to go to the higher layer was able to heal it based on the descriptor policies. And in this case, we saw, in the scaling case, we saw OSM rise an alarm to the higher layer. An NS update was called to edit the policy, and OSM automatically took the policy, did the scale, and then created the twin UPF twin, right? Of course, all combinations are possible. You want to do heal from the higher layer, you want to do scale as closed loop, it's possible. We just did it this way to give you to showcase to you the flexibility we have when it comes to service assurance. So let's go ahead and see if the scale happened now that I've given you an intro of what we do for scaling. So let's go to NS instances, let's go to UPF demo, let's go to history of operations, and we see that the scale operations has been successfully completed, right? So let's quickly run through this. We instantiated the UPF. We did an NS update to combat the new load in traffic. So I updated my policy of my UPF to include scaling, and OSM successfully scaled out to create a replica to handle the extra traffic. Let's take a view from the NFVI as well. And here we see that there has been a UPF twin created to handle the extra traffic load. So with this, I conclude my demo. So to quickly recap, OSM, we are out with release 12, and what we saw today was a real-world example of OSM and service assurance operating in multiple form factors, either as closed loop or as policy driven from a higher layer, and all of it as zero-touch automation. Right? Just mention your intent, OSM takes care of the rest. And we saw it for a real-world example where for operational failures or a sudden spike in traffic, OSM in a sport event was able to give the service continuity for the customers of the operator. Thank you.
Thank you. Thank you, Ramesh. So, well, we are in the Q&A part of hopefully we can see our presenters now. Okay, so that's all that we have in the contents of the webinar, but the webinar is not finished because we have questions from the audience. So maybe we can take them one by one. So there's one question: how can I have these packages? So apparently they have been interesting. So they want to recreate the use cases. So any answers to that? Well, I think this one is easy, by the way. So we regularly publish our packages of examples.
Yes. Yeah. Well, I will take, at least for the demo of the CNF upgrade, I can tell you. Okay, let me share my screen. I will show you how to reach them. All the OSM packages that we use are published in our GitLab, osm.etsi.org/GitLab. And here, if you log in, you can go to the OSM packages and you will find all of them. In this case, the ones that we are using are this OpenLDAP Cnf. The version of the updated network function I have not yet pushed to the Git repository, but I will do it in this week or next one. Okay, and you will be able to find all of them in this. All the packages that we use can be found here in this OSM Packages GitLab repo under osm.etsi.org. Ramesh, I don't know if you want to comment about yours, the ones that you were using in your demo.
Yeah, absolutely. We'll upload it into a similar package structure as well, so it's available for the community. We'll get that done by tomorrow.
Okay.
Okay, very good to know. Oops, this is the auto spotlight that did not show all the faces. Sorry. So, well, which version of Openstack was used for auto healing and scaling? I would dare to say that there's no
Rocky.
requirement. Which one did you use, by the way?
Rocky.
Okay, but in general, I don't think we have a strong requirement on the OpenStack version, right?
Exactly, you're right. You're right. OSM, well, one of the components of OSM, the resource orchestrator, has different connectors to the beams. And in this case, there is a connector to OpenStack. That connector is, let's say, hiding all the complexity and is prepared in principle to work with any version of OpenStack.
True.
So all this healing capability is relying on those connectors. So in principle, no problem.
Yeah, because actually the extra intelligence is created by OSM. It's not relying on any embedded mechanism in ANIAS, So in the end, is compatible. Okay, we have another question about. Well, thanks for the webinar. Thanks to you for attending. And the question is about: is OpenFlow still used much with OSM, especially Release 12? Well, I would say that we are supporting and we are quite agnostic on which technologies are used, as long as they are supported by OSM, and OpenFlow is supported by OSM for a long time, so we are not particularly opinionated. I don't know if you have
No, yes, we are still supporting it. OSM has a feature that it's called Sdn Assist. That feature, what means is that OSM is able to control or to talk to an Sdn controller in order to interconnect data plane interfaces of virtual machines, right? This is, for instance, used to interconnect SRIOV interfaces from different virtual machines, etc., right? And OSM has this plugin model that allows you to interact with different elements. In this case, for the SDN controllers, we have the same, right? So we have different plugins or connectors to talk to different SDN controllers. And one of the plugins that we have is the OpenFlow connector that is, well, in principle, designed to send kind of OpenFlow commands directly to the SDN controller, and the SDN controller passes them to the switch almost directly. Right.
Okay, very clear. Okay, well, congratulations for the presentation. Thanks to you. Very generous of you. Do you have any plans to do a Hackfest about this version? I'm glad to say that you are asking. Yes, we are. We are planning. Actually, we are planning to run it in the upcoming Networks event in Amsterdam. So we we hope to see you all of them, all there, and there we will be quite special Hackfest for OSM, by the way, because it will be after pandemics the first big event that OSM is organizing after the pandemics in an open venue. Okay, so we are quite excited about one. It's a lot of work, as you may imagine, but as community, it's a big event for us, and hopefully we'll see all of you there. Okay. What else? I see that the list is growing as we go. Okay, OSM list. Okay, OSM release 12. I've lost it. Sorry. OSM release 12 defines some APIs of which type.
Yeah, maybe I can share my screen also. It's pretty straightforward. Francisco-Javier already mentioned that one of the features included in OSM is the support of SOL003, right? So that means that we have added in OSM Northbound interface the APIs from NFV-SOL003 related to the management or lifecycle management of ENF. So all of them are captured in our GitLab again, or in our repositories, let's say. I can show you here.
And Sol5 as well, right? We support Sol5 as well for.
Obviously, yes. The new ones that have been added in release 12. Yeah, you're right, Ramesh. Yeah. The new ones are Sol3, and the ones that we have added for healing, for update of a network service, those ones. Let me just go pretty quickly to the screen here. If you go to our VNF onboarding here, if we go here to our GitLab and we go to Sol5 repo and Sol3 repo, those repos here contain all the specs that we are following and the way that we are implementing them, right? The actual implementation is in a different repo, but all the documentation is here. And you could see, if you go to the YAML file, the API here, and you will see here represented. This is a Swagger file, okay, and you will see here all the APIs. In this case, for instance, the new ones are the heal, right? This has been added to heal a network service instance. Also, you see here the details, right? The migrate, it's in order to migrate BNFs in a network service instance, and also the update, to update a network service instance, and vertical scale, to scale vertically a network service instance. Those 4 calls have been added in this release. In addition to that, we have, these are the 5, let's say, or that are extending or based on what it's in Sol5, right? And the other is Sol3 here. In this case, this is not automatically generated, I think, but you could see here in source Sol3 all the information here. The automatic generation, I'm not sure if it will work, but you will be able to see all the APIs, right? So BNF instances, you could find it here, okay, in this repository.
So in case that someone is planning to do anything super fancy interacting with OSM, you can find there all the documentation in those repos on all the APIs.
Exactly.
Okay, so it is way more verbose than a short answer. There's another question. How long does it take to auto heal? And is it possible to reduce the time?
Auto healing, auto healing takes around it's pretty around say 3 to 4 minutes. The time delay can be reduced, so it depends on how often you want to monitor your network, right? So when we have a service assurance module, we have a monitoring interval. So the delay is kind of like the average of the size of the monitoring interval. So for example, we have it around 8 minutes now. So on an average, it takes 4 minutes to heal. If you want something more aggressive to heal faster, you can always reduce the monitoring interval time and get faster times. But from OSM perspective, it's instantaneous. There are no delays. And once we detect the metric, we immediately trigger the action to the NFV.
Yeah, I think that one of the things that obviously the healing that comes with Kubernetes and KDUs and all the like, that was already granted and has the speed of a Kubernetes environment. What I understand what we are commenting is the added functionality related to VMs that has the times of the VMs that are different as you know. So we are trying to find that compromise in the world of the VMs that by their own nature, if you need to respawn a new VM, it will take the time that is required in the cloud where they are running it. But obviously the times are different due to the difference in the technologies, right? Okay, there's another question. I do have a problem on case monitoring. Well, it's a parameter in the installer, so maybe this one is for super experienced users. Of the OSM installation with Grafana and Prometheus not work properly for me without that option. So he's found a workaround for something that was not working for him. Please check it. My network configuration should use VPN. Okay, who can give him a clue on how to solve his issue?
Well, I'm taking care of the installer in general, the community installer, so I could probably answer this one, right? Well, what I would suggest is that if there is any issue that you are experiencing on that, and this is kind of support question, right? And I think that the most reasonable channel is to use Slack. We are present in Slack. We have our own workspace in Slack, opensourcemano.slack.com. I think that I'm trying to find, yes, it's here in the web page of OSM. I'm going to share my screen. You see here my screen. In contact, you see here Slack workspace, and that will redirect you to our workspace. And if you ask there in the general channel, well, we could try to debug an issue that you might have, right? That's probably much better, right? Because the issue could be different depending on the case, right?
Yeah, in general, there are all kind of questions there. So well, people can help you and share examples that they have created similar to the use cases that you are planning to do, etc. It's quite effective. Probably the easiest way to get interaction with community for troubleshooting and quick help. This is the best channel. I mean, there are other means to contact OSM community, of course, but if you need something for tomorrow, probably this is the easiest channel, and there are a lot of eyes there, right? So, well, how about the scaling auto healing package? I think that we have covered this one because, I mean, Ramesh has mentioned that he will be.
It will be made available.
Okay, so this one is covered already. Anything about artificial intelligence, machine learning in relation, for instance, in relation to healing? Well, this is a good question. I mean, we need to be very careful on these topics because, I mean, besides the experimental, I mean, you need to, I mean, this generates some tension on people who are operating networks for real with OSM, which happens right now in a lot of places, right? So the problem with artificial intelligence, for those who are familiar, is finding in the diagnostic a good balance between precision and recall and training that so you don't make any mistakes either in one direction or the other, particularly if you are taking proactive actions to heal something that you are not breaking anything that is working, and which can happen surprisingly. It's acceptable in some other environments, but maybe in a network is a bad idea. So we are being quite cautious in OSM on announcing that functionality. It doesn't mean that we are not doing work on that area. The first step is obviously being able to share the raw data so that we can train models outside. So we are providing the technical means, obviously, for generating those AM models. The other thing that is probably not part of the things that could be provided as inputs in the software is having realistic raw data that can train the model, right? So in an open source community, it can be a bit complicated given the sensitivity of the real deployment, right? We are still need to figure out how to incorporate raw data, because in the end, training a model is, besides the trade-offs on precision and recall that I mentioned, the problem is that you need to have a significant amount of cases that are properly labeled and that they are realistic enough. So you are not training on super in corner cases or very made up cases that in practice will not work out and will not train properly a model, right? So we are providing the technical means, and as part of the technical means, hopefully we could gather that data and work accordingly. And if anyone wants to build their own models at their own environment, of course, by using the data provided by OSM, OSM gives you also the APIs to create an external feedback loop if you need to, right? So all that is already available as long as you are developing your own intelligence adapted to your own environment. Okay. Okay. Anything else? Okay, but for supportive, but still require use often. We have no idea, honestly. The thing is that depending on the environment, I mean, there are in academia you see almost everything, particularly related to if you have some physical hardware and they do whatever that they need. In commercial environments, probably you go for other type of SDNs. But from community perspective, those insights are not obtained. You know, per company they have their own opinions. I don't know if you guys want to elaborate.
No. Just to clarify that we don't require any kind of interaction with OpenFlow in OSM, right? It's part. If you are interacting with an SDN controller that supports that OpenFlow API, let's say, you could use it if you want to. Okay, only that.
Yeah, it's not a pre-requirement for using Sdn Assist or anything. It's not mandatory at all. It's one of the choices that I mentioned in the introduction, one of many, right? But that has been quite popular for a while, has been probably the starting point for the SDN concept somehow, but nothing else. And last, I see another question. Do I need to add to the Openstack Nokia oscillometer for monitoring? Yes, right?
Yeah, I don't know if it's related to the healing. Probably the question is related to healing. Well, it's kind of in general. I think the beam connector for OpenStack in OSM uses Nova API to know VM state or to know if the VM is okay or not. I think that's what is used.
For scaling, it's required. For healing, it may not be required. For scaling, yeah.
Exactly. Mm-hmm. For scaling, yes. For healing, not. Exactly.
Yeah, I mean, you can trigger it manually if needed, right?
Also,
okay.
Yes.
Okay, and I think that is also so we can close the webinar here.
Yes, thank you very much, Francisco. First of all, I'd like to thank you and your colleagues for the time you've taken to make these presentations, and also then to ask the questions and answer them. And I hope that people will have benefited from your experience and knowledge. So as time is running out, I'd also like to thank the audience again for listening to us, and also to ask them to keep an eye on the ETSI Bright Talk channel for any future webinars that we make on a regular basis. So once again, thank you and goodbye.
Thank you. Bye.
Thank you. Bye.